Question 3. So they're telling me in the question that copper sulfate solution was mixed with sodium hydroxide solution, and a precipitate of copper hydroxide and a solution of sodium sulfate were formed. Okay, so I'm going to just highlight here that I know that these ones are solution, this one is a precipitate, and this one is a solution. I'm just going to remind myself here, in case I've forgotten, that a precipitate is a solid. So I'm just going to write that there just to remind myself in the question. So bottles of both copper sulfate solution and sodium hydroxide solution can have a hazard symbol on them. So here's the hazard symbol that is shown. So give a precaution that should be taken when using copper sulfate solution or sodium hydroxide solution, as this hazard symbol is on the bottle. Okay, so this hazard symbol says that I need to be careful when I'm using this solution, and so I'm going to write here that I would wear goggles, or I could wear some gloves. Those would be precautions that I would take. Then it says the equation for the reaction is copper sulfate, CuSO4, AQ. So I know that AQ, I'm going to write that here, stands for aqueous, which means that it's in water, so it is a solution. They've told me that already up here. Copper sulfate solution, there we go, I've highlighted it at the top. Here we go, I know that it's a solution, it's dissolved in water. So copper sulfate plus sodium hydroxide, and again, solution, they've told me that there as well, forms copper hydroxide. OH always means hydroxide, and I know I've already identified here that a precipitate has been formed. So precipitate is a solid, so I'm going to write S for solid. And sodium sulfate, again, they've told me that a solution of sodium sulfate is formed, so a solution is dissolved in water, so that would be AQ. So I've already done it, but it says in the spaces write the state symbols for each product. The state symbols are only ever going to be AQ, a solution, solid, liquid, or gas. So I've written in my solid and my solution AQ. The mass of copper sulfate solution used was 10.32 grams. So that's this one here, copper sulfate. I'm going to write that there just to remind myself, 10.32 grams of that. The mass of sodium hydroxide solution used was 5.12. Calculate the total mass of the mixture after the precipitate has formed when these two solutions are mixed together. So if I add 10.32 grams of copper sulfate to 5.12 grams of sodium hydroxide, that's what I'm going to end up with, because the mass doesn't disappear anywhere because I haven't got a gas, so it hasn't been released. I've got a solid and I've got a solution. And so actually, if I add 10.32 to 5.12, add them up, 4, 4, 5, 1. 15.44 grams, because I haven't lost any mass and these are the only two items that I've added together. So my answer is 15.44. Part D, sodium sulfate, Na2SO4, is an ionic solid. Okay, ionic. So if I remind myself of what ionic bonding is, that means that I've got giving and taking of electrons. Okay, which of these is most likely to be a property of a solid sodium sulfate? So I'm talking about the properties of ionic substances here, so I just have to know those. Do they conduct electricity as a solid? No. Do they have high melting points? Yes, they do. Do they have low melting points? No. And are they bendy? No, not at all. Malleable means I can mould them and shape them. I can't do that. And so the answer is B. They have high melting points. The formula of the sodium ion is Na+. So that means that it has lost one electron, 1-, because it has an extra positive remaining inside the nucleus. So what is the formula of the sulfate ion? So here's my sodium sulfate, Okay, now I could work this out if I didn't know the ionic formula of sulfate. You do have to know it, okay, but you can work it out. So if I know that sodium is positive, they've told me that here, and I've got 2 of them, there's the 2 to remind me, okay. When I join ionic substances together to make a molecule, I have to balance out the charges, okay. So I've got 2 pluses on this side, which means that I have to have 2 minuses on this side with my SO4 to make it balanced, okay, to make the charges can't cancel out. So that tells me that my sulfate ion must have the formula SO4 2 minus. Okay, part 3, explain in terms of electrons how a sodium ion sodium atom, Na forms a sodium ion Na plus. Okay, so I've got an explain question here. So I'm going to use PE, point explain, and I'm going to explain in terms of electrons. So I have to put electrons in my answer. So what is the point? That sodium loses, or the sodium atom, should I say, loses an electron, okay, and that means that it therefore becomes Na plus, okay, because it has lost an electron. Okay, so on to part E. So 10 centimetres cubed samples of copper sulfate solution were placed in 5 test tubes. Different volumes of sodium hydroxide solution were added to these test tubes. The volumes of sodium hydroxide solution added were 1 centimetre cubed, 2, 3, 4 and 5 centimetres cubed. In each test tube, a precipitate of copper hydroxide was formed. Okay, precipitate, remind myself, I know that, that's a solid. The precipitate was allowed to settle and the height of the precipitate was measured with a ruler. So here's my precipitate in my test tube. They've given me a diagram and here's my ruler. So I'm measuring the height of the precipitate. So the results are shown. So let's just make sure we understand this graph before we go on to the question. So along the bottom on the x-axis we have the volume of sodium hydroxide solution added. So 1, 2, 3, 4, 5, 6, 7, and then on the y-axis, the height of the precipitate formed in millimetres. Okay, so part 1, draw the line of best fit to complete the graph. Now, I'm going to draw this really carefully because the exam boards are quite fussy about how you draw lines on graphs. Ideally, you should do this in pencil, and I'm going to use a ruler. Now, best fit means that it has to hit pretty much all of the points. Okay, so I'm going to just line up my ruler here until I think that it's hit pretty much most of them. I'm going to start at my first point and I'm going to join it up to my last point. Okay, so there's my line of best fit. So I've done that. Then it says predict the height of precipitate that would be formed if 6 centimetres cubed of sodium hydroxide solution was added to 10 centimetres cubed of copper sulfate solution. This mixture would contain excess copper sulfate solution. Okay, so let's go back to this. Predict the height of precipitate. So I'm finding out the height of the precipitate that would be formed if 6 centimetres cubed of sodium hydroxide solution was added. Now I'm not just going to guess this, okay, because again they're quite fussy. So here, back to my graph, here's the 6. This is the 6 centimetres cubed of sodium hydroxide, and so what I want to do is I'm going to be accurate with this, and I'm going to extend my line. Okay, I could have done this in the first place, but I'm going to just do it now. So I'm going to extend my line so that it hits the 6. Okay, so it's now, again, I'm not going to just guess it. Okay, I've got my exam paper in front of me and I'm going to make it nice and easy for me to actually get this absolutely right. So I'm going to just find my 6. I'm going to draw a line up from 6 until I hit my graph line that I've just drawn. There we go. And now where it hits my graph line, I'm going to go across until it hits the y-axis. There we are. So I'm being really accurate here, and then I can read off from my y-axis. So 14, so there's 16, so I know that each square is worth 4, okay, because I've got 5 squares meaning 2 millimeters. So 14.4, 14.8, 15.2, 15 point, I think I'd say 5, 15.5. So my answer will be 15.5 millimeters.